Okay, we want to find all real zeros of this polynomial. So the first thing we need to find is all the possible rational zeros. So we're going to take all the possible factors of 4 and divide them up by all possible factors of 3. So we have from the 4 we get plus or minus 1, plus or minus 2, and plus or minus 4. And from 3 we get plus or minus 1 and plus or minus 3. So when we simplify these, we get plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. Now we want to narrow down which ones to use, otherwise we have to test them until we find one. So we're just going to use a graph again to test which one could be a possibility. So let's look at the graph. Okay, so we have the graph here. So as we look at the graph, and again on your calculator you can zoom in a little bit, it looks like our graph might be going through -1 there. And on the other side, it doesn't actually look like it's going through a whole number, but there are some fraction possibilities here. And I think maybe this one could be going through 2/3 right there. So let's test this out to see if there really are roots. Okay, so I'm going to test out -1 first and see what happens. So again, write the coefficients of your polynomial. Okay, so bring down the 3. 3 times -1 gives you -3. So add the column gives you -2. So we get -1 times -2 is 2. So we have -6. So -1 times -6 gives us 6, which gives us 4 in this column. And so then -1 times 4 gives us -4. So the remainder is 0. So that was the 1. Okay, so I tried the -1, and then my guess was that 2/3 might be another root. So since it's to the 4th, factoring it once gets us down to the 3rd. And we want to factor it again so we can get it down to a quadratic. So let's try the 2/3. Now, because we have already factored it, and we're just trying another factor, we're going to now use the polynomial that was created from the factoring. So just bring the numbers down from what we just found. Except the 0, we don't put down the remainder. Okay, so we're doing the synthetic division one more time. So bring down the 3. 2/3 times 3 gives us 2. So if we add the column, we get 0. So 0 times 2/3 gives us 0. So that's -6. And -6 times 2/3 gives us -4, which adds up again to 0. Okay, perfect. This second root also worked. So we have 2 of them. And the remainder of the stuff that came out in our division is a quadratic polynomial. So let's just real quick write down this polynomial. So we have f of x equals, so the first factor was x plus 1. And remember, we're doing the opposite sign. Then we have x minus 2/3. And then we write what comes from our division here, which is 3x squared and then minus 6. Notice that the x term is 0, so we can just skip it. You can write it in as a placeholder if it helps you, but then as you simplify, you can just drop the term. So the only thing that remains is for us to factor this quadratic term. Okay, so since it's missing that x term, it's actually nice because we can use square roots for this problem. Okay, so let's do that. Okay, I'm going to scroll this page up a little bit here so we have more space. the first thing we can do actually is just factor out a 3 out of that term. It's not necessary. It technically would cancel itself out if you are just looking for the zeros, which we are, but I'm just going to write this also in factored form so you can see what that would look like. So I'm going to factor out a 3 out of this. So we have 3x plus 1, x minus 2 over 3, and x squared minus 2. Okay, so we're going to factor this term. So since we're doing the square root method, let's set that equal to 0. So add 2 to both sides. And take the square root of both sides. So we're going to get plus or minus square root of 2. Okay, so those are our two factors. So let's just write this in factored form. X plus square root of 2 and x minus square root of 2. Okay, so since they asked us to list all the real zeros, they're the following. We have -1, we have 2/3, and we have a square root of 2 and a negative square root of 2. So the positive and the negative root. So those are the four roots for this problem.